Okay, on this particular problem, we've got a point at 3, -4. Okay, we've got a dot at 3, -4. And it says that this is representing an angle in standard position whose terminal side passes through the point 3, -4. Okay, and what we need to do is we're going to try to find cosine, secant, and tangent of that angle. Now, we're going to be finding this angle right there. And it's a good idea to turn this into a triangle. So I'm going to bring that up, and we're just going to, maybe I'll erase this arrow. Okay, so we're just going to be focusing on this triangle that I just drew. And we know some things. We know that this side up here has a side length of 3. And we know that this went down 4. And I'm going to use a -4. Even though we're talking about the length of the side, and usually you would say that length has to be positive, we need the negative sign to indicate that this side is going down. Okay, so it's a +3 because you're going to the right, and then a -4 because it's going down. Anytime a side points down, it should be negative, or if a side pointed to the left, it should be negative. And we're going to find theta. So we've got a right triangle. We're going to use some right triangle trigonometry here. We know the opposite side of our angle. We know the adjacent side of our angle. We should probably figure out the hypotenuse. So if we did Pythagorean theorem, we'd have 3 squared plus -4 squared equals our hypotenuse squared. So 9 plus 16 equals c squared. Add those up, we get 25, and take the square root, and we're going to get a 5. The hypotenuse is always going to be a positive value, okay? So now we're going to find cosine. Well, cosine is adjacent over hypotenuse. So in this case, the adjacent side is 3 and the hypotenuse is 5. Then we're going to find secant. Well, one thing to remember is that secant is the reciprocal of cosine. So all we'd have to do is just flip this fraction and get 5/3. And then the last one is tangent. Tangent is opposite over adjacent. So the opposite side of our angle is -4, and the adjacent side is 3, so -4/3. Okay, moving on. If sine equals 3/8, sketch a right triangle and find the other 5 trig functions. Okay, so sketch a triangle. Your angle, we got a right triangle. Your theta could go in either of these two spots. I'm just going to pick one. Okay, sine is opposite over hypotenuse, so I'm going to fill those sides in. Opposite of theta would be 3, hypotenuse would be 8. And I'm probably going to need to find this adjacent side. Here, I'll fill this in as opposite and hypotenuse. So now we're going to find the adjacent side. So Pythagorean theorem would be 3 squared plus x squared equals our hypotenuse squared. Make sure that you set that up right. The hypotenuse squared is the one that's all by itself. So 9 plus x squared equals 64. Subtract 9 from 64, and you get 55. And then we're going to take the square root of 55. And if that simplifies, do so. But if not, just leave it as a square root, as a radical. All right, so we're given sine. Let's find cosine. Cosine is adjacent over hypotenuse. This is the adjacent side. So it would be root 55 over 8. Tangent is opposite over adjacent, so that would be 3 over the square root of 55. But we don't want to leave a square root in the bottom, so we're going to multiply by the square root of 55 on top and bottom. So then we have 3 square root of 55 divided by 55. Okay, which function is the reciprocal of sine? That's cosecant. So we're going to just flip this and get 8 over 3. Which function is the reciprocal of cosine? That's secant. So we're going to flip this fraction, which would be 8 over square root of 55. And again, we're going to have to rationalize the denominator, multiply by square root of 55 on top and bottom. So we'll get 8 square root of 55 over 55. And then the last one is cotangent. Cotangent is the reciprocal of tangent. So you could take and flip the answer, but then you're going to get a radical in the bottom. So I would take and flip this original one. That would be the easiest one to flip, because when you flip this, you're going to have square root of 55 on top and 3 on the bottom, and then you don't have to fix anything up. Okay? Okay. We've already kind of been using these different things. If we're going to find more sides, then we have this setup here. We can label our sides. So if this is our angle, then 3 would be the side opposite, 6 would be the side adjacent, and then we could find the hypotenuse. So 3 squared plus 6 squared would equal our hypotenuse, so it's c squared. So 9 plus 36 equals c squared. We would get 45 equals c squared. So the square root of 45 would equal c. And then is there any perfect square that goes into 45? Okay, and 9 goes into 45 5 times. So we could write this as the square root of 9 times 5, and then split them up, square root of 9 times square root of 5. And the square root of 9 is 3. So this would equal 3 radical 5. That would be the hypotenuse. Okay, so now from here you could find all of your trig functions. So let's say we found sine. Sine is opposite over hypotenuse. So that would be 3 over 3 radical 5. Okay. And technically the 3's would cancel, so we would have 1 over radical 5. But we need to rationalize that denominator. So then we would end up with radical 5 over 5. If we wanted to find the reciprocal of that, it would be cosecant. And you could choose, do you want to flip the original one? Do you want to flip this simplified one? Or do you want to flip the last one? Well, I would not suggest flipping the last one, because then you're going to have a radical on the bottom and you're going to have to rationalize it. So how about if you flipped this one, then you would have radical 5 over 1, which is just radical 5. Okay, I think you could find the rest of the trig functions from there. All right, let's say we're doing a solving problem and you're given the angle now. You're given a side and a missing side. We'll start from the angle that you're given and label some stuff. So across from the 64 is the opposite side. Across from the 90-degree angle is the hypotenuse. So you have to figure out which formula should I use. Well, which formula deals with opposite and hypotenuse? Maybe you write out the little SOHCAHTOA thing. Okay, so which function deals with opposite and hypotenuse? Oh, look, sine. So we're going to do sine of 64 degrees equals the opposite side, which is x, over the hypotenuse, which is 32. Okay, now you can put that over 1 and cross multiply. So now we're going to have 32 times sine of 64 degrees equals x. Make sure that your calculator is in degree mode. So you'd have to go to your home button and click on settings, which is number 5, and then click on number 2, document settings, and make sure it's on degrees. If all of that checks out, then just type in your calculator. Hang on just a second, I'm getting my calculator up. Okay, so we're going to do 32. Oops, hang on. Okay, so type in 32 times sine 64 degrees, and you should get 28.7614. Okay, double check, actually type it in your calculator and make sure that you got it to work. Okay, let me just show you how to do it on the calculator. So you're going to do 32 times, and then press the trig button to open up this menu, and we're doing sine, and then 64, and hit enter, and there you go. Okay? All right. Next problem, we have a 40-degree angle. The side across from it is 30, that's the opposite side. The side next to it is the adjacent side. So now which formula should we use now? Which formula deals with opposite and adjacent? So look up here. Tangent deals with opposite and adjacent. So we're going to do tangent of 40 degrees equals the opposite side, which is 30, divided by the adjacent side, which is x. Now just be careful, because when you cross multiply this time, you're going to have x times tangent 40 degrees equals 30 times 1, which is 30. And if you want to get the x alone, you're going to have to divide 30 by the tangent of 40 degrees. Okay, so let's get the calculator back up. So I'm going to do control divide and get my fraction bar, and then do 30 divided by tangent of 40 degrees. And we get 35.753. Okay,